this video, I will show you how we can simplify an inverter so it's much easier to analyze. So what we do is that we look at the inductor. So on the left side of an inductor, we have a voltage. This voltage we call VC. And on the right side of the inductor, we have another voltage, which is VAC, which is the voltage coming from the grid or something else. So basically, we want to control VC here such that we get the desired current that we want. So the inverter basically generates VC to get the desired current that we want. So it is actually a controllable voltage source. So VC is a controllable voltage source behind an inductor. And then we have the grid voltage, VAC. So in order to control the current that we want, we just need to control VC. But how do we find VC? So it is given by the two legs in the inverter. So you can see that we have a voltage here that we generate, and then a voltage here that we generate. I say generate because we can control the gate signal such that we get the desired modulation voltage that we want. So for example, when the gate signal is 1, we know that this MOSFET is open, so this voltage is equal to this voltage. But when it's 0, this MOSFET is open, so this voltage is equal to this voltage. So we can actually write up an equation for this. So we get that VM FL is equal to VDC and then times the gate signal. So when this is 0, we get that this is equal to this one, which is VDC. Sorry, when it's 1, this is the case. And when it's 0, this voltage is equal to this voltage, so we get 0. And we can do the same for the slow leg. So we have VM, and the slow leg is equal to VDC times the slow leg gate signal. So I call these slow legs and fast legs, but you can use whatever PWM strategy you want. It doesn't really matter. We still have one leg here and one leg here. I just use the slow leg and fast leg terms to distinguish between the legs, so it's easy to distinguish. But whether both of these switches with the same frequency doesn't matter. So you can see that to get this voltage VC, we can take the fast leg voltage and then subtract with the slow leg voltage. So VC is equal to FL minus VM SL. And this can be rewritten as the DC link voltage and then multiplied with the fast leg minus the slow leg. So that is basically what VC is and how a controller and how a generator generates a voltage. So in this document, I actually go through how an inverter works in detail. So you can see that I explain it here. So you can see that here we have the voltage generated by this fast leg, and here we have the voltage generated by the slow leg. So we take this one minus this one to get the converter voltage that we generate with the inverter. So this is a course I have made on bidirectional inverter. So it is a course where we look at how to control a inverter. And it works in both directions, so it could be a rectifier and an inverter, but we will focus on the inverter part in this course. So we go through two types of control methods, which is the ABC coordinate, which is basically a stationary frame. It's a simple one. And then a DQ coordinate, which is the one you, for example, use for grid-connected inverters. So here is the block diagram for the control in ABC coordinates. Here is the power measurements. So this is only for active power, as you see. And then we have the power controller, and then we have the current controller, and then the PWM. And here's the control circuit for the DQ. So this is just a way to, so the OSG is basically a way to transform from ABC coordinates to DQ coordinates. Then we have a PLL to find the angle of the grid voltage. And here we have the power measurement, which finds the active power and the reactive power. And then we have the power controller, and then the current controller. And then we transform back to the ABC coordinates. And then we have the PWM. So in this course, I will be explaining both these two in detail and also comparing them. And you can see that there are pros and cons for almost all of the methods that we use here. So if you're interested in this inverter course, go to the link in the description.